Tiwong, but no, I'm not Ajahn Tiwong. Ajahn, your official instructor is actually in the back, and I'm sort of like his helper.
I'm always in the back watching every single one. On the screen.
Before we begin, I want to tell you a little anecdote, a little story from my undergrad years. We had to take physics as one of the required courses for electrical engineering. And I still remember the first day that I went to the class. And the first thing that the professor said was, welcome, freshmen. This class will be very fun. Welcome to hell. And indeed, it proved to be hellish, the whole quarter. We had a quarter system, not semester system. So why did I bring this up? Well, if you guys don't know what Tartarus means, it basically is the deepest part of hell. So that probably is indicative of the workload and the difficulty of this course. I bet that none of you has taken a look at the syllabus, but we'll be sure to cover that today. So expect to have quite a bit of workload than what you were normally used to, okay, for this course. All right, without further ado, now I'm going to get started introducing going over what we're going to cover today. All right, so the agenda for today is I'm going to introduce myself a little bit for those of you who don't know me. And you guys are also going to get a chance to introduce yourself to me as well, because I believe, I want to get to know each one of you, okay? Then we're going to go over the course syllabus, the rules for the class. And then as for the content today, we're going to cover things that you should already know as an ICE undergrad, tools, and of course, this is a programming class, so it's Java, things related to Java and software engineering, okay? Okay, first thing first, my nickname is Pac, like Pac-Man, not Pack like Packer, people who pack stuff, Pac, just P-A-C. I actually don't like it when people misspell my nickname, like P-A-C-K, P-A-X, it's just Pac, P-A-C. This is my contact. I am now regretting that I put this up because after I took a look at the first homework assignment, I feel like I will be getting a lot of phone calls. But those are my contacts, and you can feel free to contact me, WhatsApp, Line, email, Facebook. Feel free to add me, perfectly fine. Everybody's in the right class, right? This is application programming. Just want to double check because last semester I was the instructor for Introduction to ICE, and on the first day we actually had quite a few students who were in the wrong class, and they sort of sat through the first 10 minutes. All right. All the lectures will be uploaded, so even if you don't have, you didn't finish writing this down, you'll have access to the lecture later. All right, a bit about my past. I was born in the US and lived there until maybe I was 4 years old, and then I had a chance to come back to live in Thailand for another 10 years. So I went to St. John and then Saathit Pathumwan, the grade school here. And then after that, I went back to study in the US starting from high school. And I lived there for 16 years, high school, undergrad, master's, and worked there as well. I went to UCLA for electrical engineering and USC for computer science. After I graduated from UCLA. I went to work at a defense subcontractor company called Raytheon. We built like submarines, real-time embedded system stuff. And after that, I spent a year in Michigan working on web development, things like web applications like Twitter, Facebook, those kind of Web 2.0 web applications. And sort of like in my past life, I was a software programmer. On your left-hand side was the kind of stuff that I worked on at Raytheon. We built that little autonomous unmanned vehicle, the yellow submarine-like vehicle. And the kind of stuff that we did was the vehicle had sonar attached to it. And based on that sonar, the signal, we converted it to be stuff that you see on the bottom left, which is what you'll see on the computer screen. Essentially, we try to show the image of the seabed in real time as a feed. Okay. Those were my coworkers on the top left. And when I went to work at Atomic Object, we worked on Ruby on Rails, which is a web application framework. And it is my hope that in this class, you guys will get a chance to try it out. Yeah, because I think as a software engineer, I think it is imperative that you know how to do a little bit of web now, because pretty much all sort of applications these days, or the popular ones, are web-driven. Yeah. All right. So what am I doing in the present moment? So I teach at Juฬa, yeah? And one of the classes that I've already taught is Introduction to ICE. So this is my second class, application programming. And besides teaching, currently I am a political advisor to the ex-governor, yeah? Mom Sukhumpan, yeah, Bolipat. So I'm currently helping him on the re-election that's coming up, which will end on March 3rd, I believe. And at the same time, I'm also trying to get into management consulting. So I've been studying that as well. And lastly, so those are the things that I've been doing for the past 5 months or so. So I made a transition from a software developer to be a lecturer/consultant, or hope to be a consultant. All right, a little detour. So your underclassman, yeah? He wanted me to help advertise. Okay, sorry that this is in Thai, but he wanted me to help advertise his service called Tarit Alliance. I haven't used the service. I don't think I'm allowed to. But, well, now it's been advertised, so. You can tell him about that. Okay, so interests. I have not that many interests. The first and foremost is that I like to read. I always tell my friends that the best kind of gifts that you can give me is books. I love to read books, and I like to read all kinds of books except the books that like have a lot of math. I like to read history. I like to read philosophy. Yeah, all kinds of books. I also like to study or have keen interest in the Chinese language. A lot of people ask me why I like Chinese. I just like it. Yeah, don't really have a particular reason. I'm also interested in Buddhism, particularly the meditation aspect of it. So I practice daily the samadhi, the concentration practice. And lastly, I also am quite interested in healthy lifestyle, so eating well and exercising. So those are kind of like my interests that I can publicly disclose. All right. But if I had to talk about myself, it would not be complete without talking about my passion as well. I believe to have a complete life or a more fulfilling life, you gotta have some sort of passion, things that you're really passionate about. And I feel like I can't tell you completely who I am without actually telling you about my passion as well. So things that I'm proud of so far in my life, first would be this system that I spent 4 years on. It was really the love of my life for those 4 years. I spent every day, basically it was always on my mind. If someone asked me like, what is my passion, the very first thing would have to be the system that we built when I was at Raytheon. And I was really proud that we finally were able to push the product through into the market and being used globally. And the second thing that I did not think or did not know that was going to bring me much happiness was the introduction to ICE class that I taught last semester. This was the picture taken on the last day of our class. And, What? Oh, scusi. Oh, yeah. So we had pizza and we had donuts. But it seems like your underclassmen really like scusi. So, have you guys had scusi? Yes? The pizza. It's pretty good. I mean, better than Pizza Hut. Does that say much? All right, so next thing is, I actually thought quite a bit about whether or not to include this slide today because we have so much to cover today. I'm not kidding you. But I feel like, it's the first class and it's worth it just to introduce ourselves properly. So I just want each one of you to just stand up, state your name, your nickname if you have one. For the foreigners, sorry. But I mean, are you guys familiar with the concept of nickname, the Thai nickname? All right, that's fine. So if you guys don't have nickname, that's okay. Just state your name and perhaps one unique thing about you, so that I can remember. Does that sound good? Okay, so I guess we'll just go from front to back. Not good. Okay, stand up. Yes?
My name is Harin Zakira, and my nickname is Good.
One unique thing about you. Huh?
I can't think of one right now.
Okay, that's unique. That's one unique thing about you. You can't think of one.
I can be thanked for studying.
Okay, your turn.
My name is Puthi Anulodpun. I don't have a nickname, and that's unique about me.
So you don't have a nickname. Okay.
My name is Wasin Washiralilo. My nickname is Bolt. I am very good at badminton.
Okay.
My name is Medhat Deshisanana, and my nickname is El. The unique thing about me, I think, is I can laugh any single moment in my life.
If I gave you an F. The TA too. This is your TA, by the way. Yeah?
My name is Sumadesh Chandravichai. My nickname is Por, P-O-R, and I am a TA of the
Hey, I'm Didier. I come from France, and I don't have nicknames because in France we have this, and I love selling.
Selling. Okay, cool. Is this your first time in Thailand?
Yeah.
Okay, cool. Welcome to Thailand. Okay.
Hi, I'm Shazin, and I come from France too. And that's amazing that I think about. Sorry.
Okay.
My name is Patra Paulina Chakun, and my nickname is Tae.
Jae.
I'm afraid of falling.
You're afraid of falling. Okay.
Dear Sahadi Chandra, my nickname is P, and I have quite a lot of interest in Apple product.
Okay. We'll get along just fine. Speak up, speak up.
My name is Napolung Kadrong. My nickname is Kulung. One unique thing about me is my fingerprint.
Your fingerprint. We'll have to talk offline about your fingerprint.
My name is Kiranat. My nickname is Nat, and one unique thing about me is somehow when I drive, I really hit at the unmovable object. Yeah.
My name is Nimpong Tharatip, and my nickname is Tom. One unique thing about me is having him as a friend.
What?
My name is Niran. You can call me Niran. And I think my laugh is unique.
We'll hopefully you will get to hear it, yeah?
My name is Nadanai, and my nickname is I am a big fan of Manchester United.
Oh.
My name is Prince. I don't have a nickname. My unique thing is having him as a
It's not unique anymore. Anyway.
My name is Shovin. My nickname is Golf. One unique thing about me is I like to play game online.
Okay, that's actually like most all of you know.
My name is Kasin. My nickname is Not. And one unique thing about me is I sleep too much.
Okay. You won't be getting to do that in this class.
My name is Hana.
Mm-hmm.
I'm from Busan.
Susana. Uh-huh.
Busan.
Susana. Okay.
And one unique thing about me is that this is my first class this semester.
Oh, okay. Cool.
I'm Atisha Shikarajan, and my nickname is Phil. One unique thing about me is I like to be shalom.
Oh, you really?
My name is Vishana Avatahi. My nickname is one unique thing about me is that I like watching series.
Oh, you like watching series.
My name is Marisa Ablati. My nickname is Kay. One unique thing about me is like my friends tell me that I look like Winnie the Pooh, but I don't think I do.
Hello, my name is Kinky Rizit. My nickname is Wanti. One unique thing about me is that I like to play different kind of sports.
Oh, okay.
My name is Pierre. I'm studying the English Peter as well.
Peter.
People used to call me Pete. And one thing about me, I'm French.
Not unique anymore. Mm.
My name is Anika. One unique thing about me is that I have a pretty big head.
You go.
My name is Anna. My nickname is Tan. One unique thing about me is I'm from Itania Basketball Club.
Oh.
My name is Nat, and it's like one unique thing about me is I like basketball.
Last one. Oh. Okay, thank you. So I make it a goal, a personal goal, to remember every single one of you, the names, at least the names. Maybe not the unique thing about you because they're not so unique, but just kidding. Yeah, so let's see by the end of the semester, yeah, if I can remember every single one of your name. All right, so not much time to joke around, so we're going to cover the rules for this class now. All right, first of all, so only use English, yeah, when you communicate with me. I mean, you should, right? Because after all, we're in ISE. I mean, what's the point of going to ISE if you're not going to use English? So you might as well practice. And I can tell you that being fluent in English will present you with a very good advantage when you go into the work industry, because Thailand definitely need a lot of people who are fluent in English. Yeah, so I think that's the rationale for, or the motivation for why you would want to, if your English is not good now, to improve it. And also, and primarily because, you know, AEC is coming up soon. I take it that you guys have heard of AEC. Yeah? Okay. All right, so first rule is only use English in this class. Secondly, you can do whatever you want. By that I mean, you know, you can go to the restroom whenever you want. You don't have to ask me. You can, you know, do things that you want to do. But the only thing that I do not allow you to do is to disturb other people. Yeah. So if you're gonna fall asleep, just don't snore, for example. Yeah, these are the basic rules. Only 2 rules in this class. One is use English, and second is don't disturb other people. Yeah. And if there's anything that I'm not doing well, let me know, yeah? If any concepts that I presented were not so clearly explained, just let me know. I'm always looking for feedback on how to teach better, to present better. All right, a little visual riddle. What do you think this means? So what's on the right hand, huh? Okay, piece of cake. I asked the same question in Intro to ICE as well.
Getting 0 points is a piece of
Getting 0 points is a piece of cake. Yeah, that's true. But no, that's not the point of this slide though. Zero can, so that's a number 0, right? For the Brits, sometimes they would pronounce, or they would read 0 as not. So if it's not instead of 0, what is it I'm trying to say? Not a piece of cake. This class is not going to be a piece of cake. Yeah. So whoever said that he likes to sleep a lot, you better get used to changing your habit now. All right. So this class is called Application Programming. So what are we going to be learning? What do you think we're going to be learning in this class? It's on the slide. Huh? What? Programming. What else could it be? It's not a trick question like the previous slide. Yeah, of course you get to program a lot. So to achieve that, we'll teach you both the theory as well as the application. So let me define what I mean by theory and what I mean by application. All right, the theory. So what's the programming language that we'll be studying in this course? Java, right? So what is the paradigm, the major paradigm of Java? Object-oriented. So we'll be covering object-oriented concepts, both in theory as well as practice. Because, so when we think about, so to take a little detour, when we think about object-oriented, how do we express that in Java? The keyword is CL, class, right, for example. Oh, so you guys took the lab, good. Along the way, I'll try to instill and teach you guys the software engineering best practices. You know, how to construct your software in such a way that your teammates will not curse you out, you know, when they read your source code. In case you did not know, in this class, we will also have group projects, or one group project, one medium-sized group project. So you guys will get a chance to work together. And I have to consult Ajahn Atiwong whether or not you guys get to pick your teammates, or, okay, so you guys get to pick your teammates. I was thinking about like randomly choose. So working as a team, yeah, working with people is actually one of the skills that you should acquire, because in the real world, you won't be working alone unless you wanted to like do a self-startup, yeah. So the ability to get along and play well with others are actually important, and we'll let you have that experience in this class as well. And how can we allow you to take in and learn all these concepts like the software engineering best practices, or OO, object-oriented, is through app programming. So in this class, you get to program, we believe, quite a few of different kinds of application. You will get to try out applets, graphical user interface, or GUI, like desktop application. It is our hope that we'll get you guys to try out web distributed programming, multi-threaded programming. If some of these terms are not familiar to you, that's fine, because we'll be teaching you, introducing you to all these terms. And if we have time left towards the end of the course, we'll try to cover other languages, other programming languages besides Java. You didn't think that the world only had one programming language, did you? Right? Why is it quiet? So who can name other programming languages besides Java? C, right? Assembly, yeah, Objective-C. Good. Just for the record, JavaScript and Java are not the same programming language, yeah? I mean, they sound similar, but they're not the same programming language. And yes, maybe smartphone or iPad programming if we have time, yeah. So I hope you see now that by taking this class, you'll be exposed to many kinds of application programming, not just command line. In your first year, for the people who took the programming lab in your first year, maybe you guys only got to do like command line programming, yeah. So in this class, we'll take it a step further, yeah. Okay, so now it's time to cover the course syllabus. And you will want to pay good attention to the course syllabus, because we will actually give you a homework based on the content of the syllabus. I've never had to take, I never had homework that was about the syllabus before, but after talking to Ajahn Atiwong, we feel like it's a good idea to really make sure that you understand what's the content of the syllabus. Okay, so let me load up the syllabus. Oh, can I see a show of hands? Those of you who use Mac? they are increasing. Windows, be proud. Just kidding. Linux, oh man, good. What else? I think those are the major 3 operating systems. Who's using other sort of operating system? Did you make your own? Huh? DOS? You're still using DOS? Oh man. You should have said that as the unique thing about you. Oh. Hey, don't talk smack about Courseville, man. Lest you get an F in this course, and not from me. Ah. Okay. All right. First, let me say, why is it, some of you might be wondering, like, why is it that we're covering course syllabus when, our time is so precious? Well, because, at least from my experience from Intro to ICF, the students will come and ask me after they took the midterm, oh, Ajahn means professor, teacher in Thai, by the way. They come and ask us like, oh, Ajahn, so what is the grade that I'm going to get? What's the midterm percentage? And I'm like, duh, we already covered since the first day and it's in the course syllabus. Why are you asking me? So this is why we want, one of the reasons why we want to cover the course syllabus with you. Anywho, so you probably already see that to access the course syllabus, what do you have to do first? It's not public. What? What? Oh no. So I've already covered the topics that we'll be covering in this course, so I'm going to skip that since we don't have much time and dive into the calendar for our course. So, so I know you guys can all read, yeah, but a couple of key things I want to point out. First of all, no class next week. Yes, you're supposed to say that. I was like, how come you're not cheering? So next class we have university games. I've never been part of that. Don't know what it's all about. We have midterm, maybe about 2 months from now, roughly. You can see that for week 15 and 16, we have project presentation. Yeah. And as for the topics that we'll be covering, I trust that you guys can just go ahead and read that yourself at home. But I just wanted to point out that next week there will be no class. We have project presentations, and the midterm is about 2 months from now. Yeah, roughly. And I want to direct your attention now to the grading. First, the assignments. The assignments, which would be the homework, account for about 15% of the class. The midterm examination and the final examination are equal. Oh, no, not equal, sorry. Midterm is 35, and the final examination is 30%. Class project, which you spend countless nights on, is worth 20%. So now you should not ever, I should not ever have to answer you again, what are the percentages for your midterm or class project, yeah? I've already told you. Don't come ask me. And our course webpage, there are 2 of them. One is official, and another one is unofficial. First one is Courseville. Are you guys all familiar with Courseville? Raise your hand if you're not using Facebook. Good. Nobody came from China. So the very first thing, okay, for you to be able to complete your first homework assignment is that you should go to Courseville. That's the URL, course.sls-atl.com, and sign up to get and request access to our course. We'll spend time towards the end of the class, if you want, on how to sign up. Again, let me zoom in because I feel like some of you are trying to write down the URL. So that's course.sls-atl.com, and I trusted that hopefully, when I check Courseville tonight, that all of you and all of you have already signed up for Courseville. It's really easy, okay? Huh?
What's the Courseville password?
Courseville password is Tataras backward.
To register, you go to register and find the icon of this course, which
Yeah.
I think is unique enough for you to find. And then you just enter your student ID and the password that you about to give.
Yes. Basically, it's Suratrat. No, hold on. Here. This is how you. I was the one that came up with the password myself, and I, for some reason, drew a blank. Suratrat.
With the capital S.
Capital S. Although I'm not sure if that's necessary, but yes, Suratrat. Yeah. So to sign up for this course, you need your student ID as well as that password, Suratrat. So why do you think that the course password is Suratrat? It's another trick question. It's Tataras backward.
Registering is easy.
Yeah. Yeah? You see it now? So that's how you can maybe remember the password. So don't worry if you can't log in right now. After class, come talk to me if you have problems. All right. So now let's talk about attendance. Right there in bold and underlined. For you to be eligible for the final examination, you have to be here 80% of the time. Okay? I don't think I have to say anything more about that. And you already know about academic honesty, so that's that. And we have recommended reading. These will come in very handy when you do your projects or your mini homework. And I also recommend such thing called Google. That will be very helpful for you as well when you run into some problems and you're not sure about how to solve it. And later today, we'll be introducing you to some of the websites that will help you in terms of if you had programming questions, where can you go ask for help? Okay, so that's for the course syllabus. So now we're going to go back to our lecture. So now it's time to get started. We're doing good on time, I think, 9:40. Man, my remote is terrible. Okay. This class is about programming, yeah. So you would think that I would cover things that have to do with programming, like programming concepts. But before I do that, I want to cover things that I feel like programmers should be aware of, specifically computer users. First thing is computer posture. Why is it that I have to cover this? Without good computer posture, yeah, it can adversely affect your health. Okay, it can cause eye strains, muscle aches. Yeah, so the stuff that I'll be covering today will tell you how to avoid most eye strains or back pains. And these are actually very serious problems. Prolonged usage of computer, prolonged excessive usage of computer can lead to health problems. And I don't want you guys, since you guys are still young, I don't want you guys to run into those problems. So I wanted to take a couple minutes to at least make you guys aware of potential problems due to computer usage. So correct posture, yeah? These days we use laptops a lot, yeah? So sometimes we sort of hunch when we use the laptop, okay? But the correct posture is actually the one on top, and the bad postures are the one on the bottom. So you would want to avoid those postures and try to follow the postures above. So that's all I want to say about posture. Again, like after programming for 7-8 years or so, I can tell you that postures is very important. And the computer chairs will help you. So get a good computer chair if you could afford them. I wouldn't go as far as getting like a ball like that on your back. I think it's going to be difficult. A lot of times computer chairs come with lumbar support, so you don't really have to get a ball like that. Programs that help with reminding you to take a break are these kind of programs. For the Windows users, WorkRave is free. You can just download it. For Mac users, there's something called Breaks. That would be break, like something breaks. B-R-E-A-K-Z, breaks. These programs, what it does is that after you use the computer for a certain period of time, like let's say half an hour or an hour, it will pop up a dialog to prompt you to take a break. And I can't stress enough that that's really important when you use computers, yeah? To take frequent breaks. Don't use computer for like 3-4 hours straight. All right, email and email names. So we're switching gear now. This is more related to your professional life. So emails. Whose email names are still like this? Or your email address? You know, like something like t.a.n_sugar@hotmail, or names like Bobo. The best ones that I got from last semester was this one. It reads the same way, by the way. It's Thai, but it's Talit Handsome. You know, the Thai words are Talit Handsome. What am I trying to get at? If your emails fall under these categories, like the playful, the unprofessional sort of email, now's the time to change your email to be something that is more professional. So we Thais have long names, right? So I suggest maybe just the initial of your first name, dot last name, or first name, dot the first initial of your last name. For example, like mine might be Silvabut, silvabut.u. That's the first initial of my last name. Yeah, the initial of my last name. Basically, just use your name. Don't include any cute descriptions. They don't have to know that you are handsome. They don't have to know that you're a lady. Just stick with your names, yeah? And make it short. Don't make it super long. I mean, who would want to email someone with like a 17-character name? Nobody, yeah? So consider practicality and consider, being professional, yeah? Believe me, this will come in helpful when you start working, yeah? You definitely don't want to be caught with that kind of name, yeah? It does not impress the employer, really. All right, next, Dropbox. Raise your hands if you have used it. Oh, good. So maybe some of you can tell me what Dropbox is used for, or why do you use it? We're gonna pick on those who came in late. Consider it as punishment, yeah? So why do you use Dropbox? I'm looking at you.
To share and keep the file on the cloud.
Good. What else? Oh, I'm sorry, you're the second. No, I'm looking at you now. I mean, let me rephrase the question. What is unique about Dropbox? So you say to share, yeah? I mean, what are the things that you like about Dropbox? Maybe that's the question, like what do you like about Dropbox? Well, what do you like about Dropbox? She doesn't know what you like about Dropbox.
So that you can share document.
Uh-huh. Yeah. So what's the limit of Dropbox, the storage limit? 2, 3, 4, 5? No, the storage limit, capacity limit for free. The free one. 18? 18 gigabytes? When you sign up, you get 18 gigabytes? Oh, you get 2. Really? So let's do a little competition. So I take it that you have 18? Oh. So I have 7. I think I have 7 without, free. 7 gigabytes of free storage. Who has higher? Oh my God, 25? 30? Free? Oh man.
54.
Oh, no. Oh man. Oh man, I thought I was gonna beat all of you guys. Shoot. How did you guys get that much? Huh? Oh, no. Oh man. Oh, I have a university email. I think I have to go get, so if I sign up with July email, I would get 50 or 30, whatever.
Just confirm from that email. You don't need to re-register.
Okay. Well, we'll definitely have to talk after class. Okay, that's good. Well, I'm glad that I brought this up now. So we're going to cover Dropbox anyway because some of you might not have used it before. As your classmates have said, right? Basically, it's used for file sharing and backups. The really good point about Dropbox, in my opinion, is that the really important things are all backed up online, right, in the cloud. So if your hard drive failed, your computer broke, all the stuff is still saved online. To me, that's really convenient. And the ability to share your files easily with your friends, right? How do you share your files with your friends? Let's say, these two guys, they wanted to share a folder. How do you do it? Click share, right? And then put in the email address. Yeah. So it's really easy to share your files as well, right? You just have to know your friend's email address, put it in, and then boom, right there on his desktop, the folder is instantly shared. Yeah. Prior to this, we had to use email, right, as a means to share files. And the limitation of that, if anyone has tried to send large files over email, was what? What's the limit? 10 megabytes or 25, right? Very small, but with Dropbox, you can share large files, right? I think up to 300 megabytes or something. Does anyone know? I think they make it small enough so that you can't share movies. Anyway, so that's Dropbox. movies. Dropbox in practice, I think I've already. So for this class, you might. Here's a couple of use cases. You could use it to share your project files. You can use it instead of in place of email attachment, right? All right. So Google Docs. Raise your hands if you have not used it. 1? Okay, good. So I get to cover it still. So can someone tell me why we use Google Docs? We'll pick on those who came in late. So raise your hand if you came in late. Oh, see, one honest student. That's good. Go ahead.
Docs to create documents online, which you can share with other users.
Right. So the keyword, again, you see, is sharing. You'll notice that more and more these days, right, new applications are geared towards to be used collaboratively with your friends, with people that you want to share stuff. So basically, if I had to summarize what Google Docs is, it's just basically Microsoft Office in the cloud. Yeah. The drawback I just wanted to mention is that it's not as powerful as the Microsoft Office suite. For example, some of my friends who work in the finance industry, they still have to use the Microsoft Excel because some of the formulas that are provided on Google Docs is not as powerful as the Excel spreadsheet program. So can someone tell me, well, I'll just pick on someone. No. The question is, what's the killer feature of Google Docs? Like, what's the one thing that like really wow you when you use it? Collaboration. Be precise. Be precise on what you mean by collaboration.
You can use it at the same time.
You went to my Intro to ICE class. Just kidding. Right. If you haven't used this feature, you can actually live edit the same document at the same time. You can actually see the person typing, for example, like Word document, right? You can see them live edit at the same time. And to me, like, I think that's the killer feature of Google Docs. Yeah. Another thing that I really like to do with Google Docs is like for the introduction to ICE class last semester, when I published some homework, I would publish it with Google Docs. And if I had typos or I wanted to change something secretly, I would just go ahead and change it. You know what I mean, right? Because like if you printed something out and you distributed the papers, you can't really edit it anymore. But with Google Docs, you can. So that's something that I really like. Publishing editable documents. All right. This is actually Mac-centric, and I don't know if there's an equivalent in Linux or Windows. But on the Mac platform, you can download this program called Sketch. And the really cool thing about Sketch is that it's a photo annotation program. So let's say that you took a photo and you want to annotate it. You put some caption on the picture, like some arrows, and you wanted to add some images. You can do that easily with Sketch. Unfortunately, I cannot demonstrate this because like at least the Sketch on my computer is not functioning. Like I can't even take a screenshot. But I wanted to point out this program because maybe for this class, when you work on the projects, you might want to include some diagrams and you might want to sometimes annotate the images. Well, this is a very good program to do that. Normally how I use it is like I like something on the screen that I'm seeing right now. I would take the screenshot, and it allows you to specify like in what region or which area of the screen you want to take the screenshot and then annotate it. Yeah. So if you're looking for a photo annotation program, this is one. For Windows users, do you guys know if there's an equivalent program? I don't know if Windows has Sketch or not, but yeah, maybe it's time to move to Mac. Oh yeah? Okay, good. Okay, so when you guys are working on your homework assignment or programming the project for this course, one of the websites that will be very handy for you, in addition to Google, is stackoverflow.com. Raise your hands if you have not used this website before. Wow. Man, so I guess the Java lab was not that tough, huh? Huh? Anyway, stackoverflow.com is the website, like the de facto website where all the programmers in the world all the professional programmers in the world know about and use actively. So it's a website that you can go ask questions. So this is something that I actually can demonstrate. Let me see if I can. So you can see that these are the questions that people just asked recently, 1 minute ago. It's very easy to sign up, it's free. And most of the time, whenever you go on Google and you search for programming questions, this website shows up a lot. And this is why it's very popular. You can ask questions. And it's very easy to ask questions. Just put in the title of your question, put in the question description you want in the bottom box, maybe put some tags to allow other people to easily identify the types of your question, and then just post your question. The only warning that I want to have is that when you ask questions on this website, try to ask good questions. By good question, I mean complete, descriptive, and make it like you actually put in the time to ask a question. Because people on this website can be quite not nice. Sometimes they'll just vote to close your question if they deem your question unworthy of being on Stack Overflow. So don't let that discourage you, yeah? Just remember when you ask questions, try to ask them nicely. And don't ask questions in Thai, because this is a American website, yeah? Don't worry, you'll get to use this definitely in this class, because it's not going to be a piece of cake anymore. Okay, next is the command line. In this day and age where the operating system look all pretty, and some of you might not have heard or used the command line before. So raise your hand if you have not used the command line before in one form or another. 1, 2, 3. So for those of you who have already used it, when you had to use it, why? I'll pick on someone to be. Yes.
Check your IP.
Oh, okay. Check your IP. What else? This is a programming course, so you know what the kinds of answer I'm looking for. Compile, right? You can use it for compiling your code. Is the command line the only place where you can compile your code? So if we want to compile our code, what else can we use to compile our code? IDE, right? What's the IDE that, okay, first of all, raise your hand if you do not know what an IDE is. IDE. Okay. We'll cover that later today, but IDE is basically a GUI application that allows you to develop code in. And we'll show example in the class today, IDE. So what's the IDE that you guys are most familiar with? Eclipse. Anybody else ever use something else? Yeah, yeah. What is it? G? Really? I've never heard of that before. Okay, so the point is there are many IDEs out there that allow you to do development, not just Eclipse. But I believe in the Java lab in your first year, you guys were asked to use Eclipse, yeah? So this is the command line, and raise your hand if you do not know how to access the command line from your operating system. Well, for those of you who have not heard of command line before, I'm going to wait. Those who haven't used the command line before, raise your hand. Okay,
Terminal.
I'm going to show, yeah, terminal. So the alternative names, synonymous names for command lines are like terminal, console, command line. Those all refer to the same thing, yeah? Okay, so I'm going to access the command line from Mac, first of all. This is how you access the command line. Whoops. I'm sorry, I actually just, I had it, I set it my Mac such that when I press F4, it will trigger the command line. But if you were on the Mac and you didn't know how, let's see, whoops. So you can use Spotlight. Oh, okay, for basic users, yeah? I know you guys do this, right? Oh man, I don't even have. You guys normally just click on application, the application folder, right? Yeah, let me launch that. So, okay, I need to cover this because it's really important. So you would go in here in your application folder, and on the Mac, the default terminal that came with the operating system is called terminal. Where's my terminal? Hey, what's wrong? Utility? Man, you guys know it. Well, I'm sorry. I don't want to embarrass myself, but okay, we'll first go into utilities and then go to terminal. But how real men actually access terminal is, this is how we do it. We would use something like an application launcher, and then you just type in terminal. This is how real men do it. So if you're using Mac, one thing that I want you to get familiar with is Spotlight, right? The default application finder or application launcher, and also help you find files. Instead of having to go to the application folder and then try to search, right? Look for your application, you can just go to your Spotlight and just type in the name terminal, right? That's really important. So you want to know that. So you just type in terminal and then it will find it for you. Right here, applications. Yeah, easy, yeah. Another application that you can use is called Alfred, A-L-F-R-E-D. Alfred, like the butler who helps Batman conquer the world. You can type, and Alfred works very much like Spotlight, except that it's actually better. It's faster. So if you haven't downloaded and tried it, I suggest that you go ahead and try it. It's a very good program. It can do many more things than just finding the application. So I covered now how to launch terminal, yeah, in Mac. So I don't think we have time to go over like what the terminals will allow you to do, like specifically. So now I'm going to launch Windows and show you how to launch or how to launch the command line. That might take a while. So while we're waiting for Windows to launch, I'm going to just sort of compare or tell you why is it that you should care about the command line. Okay, so most of you are familiar with the operating system. You use the graphical user interface operating system daily, right? Point and click. So why should you care about the command line? The key is that with the command line, there are things that you can do that the operating system does not allow you to do. Things like compiling source code, right? Or things like string together very complex commands to achieve something. The command lines in practice that we normally use it for as a programmer are things like compilation, building the program, executing scripts, which we'll cover later in the course, searching for files, and accessing the operating system internals. For example, one of your friends mentioned that whenever he wants to ping a website, what is pinging a website? What does it do? Does everyone know what pinging a website is? Basically, check whether the website is accessible or not. So those things are things that the command line allows you to do that the basic operating system might not have. Let me check again if the operating system is up. Nope. Takes a while. So we're going to cover the text editor now. 10:30. I can't find my. Okay. All right, text editor. So can someone tell me why is it that I want to cover text editor before we move on to the next topic? Why is text editor pertinent to our discussion? Why is it important? And let me give you some trick, yeah? When I start asking you questions, start pretending like you're working on something so that don't maintain the eye contact. You don't maintain the eye contact. But no, the question is, what's text editor for? Why is it important to talk about? Hey, I asked her, man. To what? Right. Well, you can use text editor to read a file. Yes. That's a good start. So once you read the file, then what? Why is it that we care about text editor? Right. And I think that's sort of like the point why we talk about text editor, because you'll be spending a lot of time in with text editor in this semester because you'll be using it for programming, yeah, writing scripts or writing programs. So since you'll be spending a lot of time on text editors, do you agree that it's important to know how to use it real well and customize it in such a way that it will allow you to be most efficient? Yes or no? That was a question. You're supposed to say yes. So there are two types of text editor. The first one you guys are already familiar with is just a plain old text editor. The other one is what we call modal text editor. And since we don't have much time, I'm not going to cover it today because I don't think it's going to bring a lot of benefit. But the key that I want you guys to take away has to do with the next question I want to ask you. So those people who use Windows, who use Notepad to program? Oh my. No, okay. So please don't use Notepad in this course. Okay, I'm going to cover why it's actually not efficient to use Notepad to program, and rather use the text editors that I'll be sharing with you today to do programming. I'll tell you the rationales why. We're going to skip this, but so if we use Notepad, yeah, as our example, can you customize the Notepad to have dark theme? What I mean by dark theme is something like this. I think so I'm going to launch Eclipse. Oh, maybe I just use Vim. So this is a dark theme text editor. So I'm typing something here on this on this text editor, and I want to compare it with this one, text edit. What is wrong with text edit? So I guess I'm not going to ask a question, but if you remember, one of the things that I mentioned about health, yeah, eye strain, right? Do you prefer to look at something that looks like the one on the right or on the left for a long periods of time? left because it has dark screen, right? It's easier on your eyes. And I think this is one of the reasons why you don't want to use just a text editor that does not allow you to customize anything. So going back to the lecture, with Notepad, right, you can't really customize it to have dark theme or dark background. At least, I don't know. Yes? Oh, Notepad++. I see. Well, Notepad++ is different. We're talking about this Notepad. But OK, you're right. With Notepad++, you can definitely customize it, right? But this is the Notepad that I'm referring to. Man, it's like, OK, so I'm bringing wow, it's just launching up. Sorry, so we're running virtual machine, yeah? So it's a bit slow. Anyway, I'm sure you guys know which Notepad I'm talking about. And the equivalent of Notepad on Mac is called TextEdit. So when you open up Notepad, it's going to look very much like this. You can't really customize it. But he's right. Notepad++, on the other hand, is a Windows application that is geared towards programmers. So you can use something like that to program. So I'm going to quickly go over the other features that are really good for text editor. Why you would want to use a good editor that is geared towards programming. Because when you program, it also allows you to have syntax highlighting. What is syntax highlighting? It highlights the keyword of the programming language that you're programming in, right? So it allows you to easily read the code. Auto indentation, auto completion, IDE-like features like compile, debug. So these are the features that the normal Notepad cannot give you. And I think we'll cover today, when I show you Eclipse, how to use Eclipse just to review, I'm going to be pointing out the things that Eclipse has. I mean, it has all of these things, all these features. So just to be complete, these are the types of text editors that I recommend if you want to program. For Unix operating systems like Mac or Linux, you have Vim, V, right? Sublime Text Editor is the one programming text editor that I recommend for all of you because it's cross-platform. What do I mean by cross-platform? There's a version for Mac, there's a version for Windows, there's a version for Linux, I believe. That's what we mean by cross-platform. It works on all operating systems. So Sublime Text Editor, if you don't have a good text editor right now, you can use that. Notepad++, right, like he mentioned. And TextMate is Mac specific, so it's only available on Mac. Text editor demo, I'm going to skip that. But the takeaway today is that I hope that when you work on your homework, you will not be using Notepad. The Notepad, not Notepad/TextEdit. Yeah? Use a text editor or IDE that's geared towards programming because it allows you to work faster. All right, so we mentioned IDE, right, or Integrated Development Environment. And this is an example of an IDE. This is what it looks like. You might ask, like, why do you care about the IDE? Well, in addition to being a text editor, it also allows you to debug your program as well as build and compile your program. These are the concepts that you should already be familiar with since you took the Java Lab application. Yeah. And we're going to cover how to do all these things today with Eclipse, just real quickly. So IDEs are not like silver bullet, right? There are actually downsides to IDE as well. The trade-off that you get with the Eclipse IDE or any IDEs is that sometimes it feels bulky. By that I mean sometimes you just want a text editor. You know, you don't want all the extra stuff that come with it. So that's is shown because that happens because sometimes an IDE is loaded with so many features. Yeah, and a lot of IDEs actually cost money. Okay, they're not free. So the one that we officially support for this class is the Eclipse IDE because you guys had experience with it already. If some of you are not so familiar with the IDE, just feel free to come talk to me after class and I'll be happy to help you out getting you familiarize yourself with the IDE. So with that, I'm going to demo Eclipse, but it's not going to be a traditional demo. I want to pay attention, pay attention. All right. First thing. What? All right, this is Eclipse, right? So you want to sort of jot this down, yeah? Once you download Eclipse, the very first thing that I want you to do before you start programming is to configure it, because this will help you program better. You want to go down to the editors, text editor here. Normally what I do is I change the tab width from 4 to 2, as well as clicking on here to insert spaces instead of tabs, because the default tab width that comes with Eclipse is 4, and I think 2 is enough. Because once you have many nested level of indentation, right? If you have 4 instead of 2, it will go like a lot further. So if you only have 2, then it allows you to put more in your code. You want to turn on the line numbers. And if you want to change the text size, you can click on here, color and font, to configure the text font. You can edit it here. So I'm just showing you so that you guys are aware that you can actually change the looks and feel of your Eclipse. So the font that I normally like to use for programming is Anonymous Pro and size 14. Because sometimes when the font size is too small, you have to squint. You know, it's very hard to read. So those are the things that I want to cover real quickly. And assuming that you have done that, then to start building a new project is very easy. You can press, I believe, the keyboard shortcut. Get used to those keyboard shortcuts, yeah? But for now, I'm just going to use the GUI to create a new project. So you can create like a new Java project, and you can name it whatever you want. Let's say project. I can't see, but anyway. So project 2, and just hit finish. So this is how you would create a new programming project in Java using Eclipse. And if you want to start programming, normally you would just right-click on here, the project that you just created. So slow. And then just do a new class. This will basically add a new class to your project. Package, is, I'm not sure if you guys know package. It's like C++ namespace. We can call it appro, and then the name can be whatever, like project. Very hard for me to program on here, but okay. So that's how you would create a like a new file, a new class. One thing that I want to point out is, do you see how I configure my text editor to look different? If I probably will upload like an instruction later on how to change the theme to be dark theme like this online, so that if you guys are interested in using a dark theme instead of the default Eclipse theme, you'll know how. Okay, but for me, I personally like my text editor to look like this rather than the default, white background. When you save the text, the file that you're working on, it automatically tries to build and compile, or compile and build the project. So if you have, what is going on? I'll check later. So this is like an example project that I had last night. The one thing that is nice, as I mentioned earlier about Eclipse, is that every time you make changes and you save, it automatically tries to build and compile and build right away. So in this case, since I have a syntax error, it already shows that, okay, there's something wrong. Okay, so in other words, Eclipse developers that built this IDE, they try to make everything seamless. So when I fix the, whoa. So now I have another typo. It's very hard for me to type and talk at the same time. So that's an example of, that's not really an example of compile and build, but just to show you the feature that with Eclipse, it automatically detects for you where are your syntax errors, okay? By those X's, what? Those X's. We're not gonna cover debugging. The next stuff that we're gonna be covering is JUnit. All right. So it seems like there's a lot of Facebook activity going on, so I need to go take care of that. But I want to say that now it's 10:30, so let's take like a 10-minute break. So come back at 10:35, and when you come back, I'm going to stop standing here and I'm going to sit there so that I can actually program properly. And we're going to cover JUnit, which is how to test your Java application. And I'm going to like create a live application. Okay, so go ahead and go take a break. I'm going to go take care of Facebook. You see? And the width and the height is 60. Do you see that? And that's how, if you just executed these two lines, all that you're going to see is the magenta square of height and of dimension 60 by 60. Is that clear so far? And the rest of them is pretty easy to follow, right? The next one that you want to draw is the blue square. So you just set the color to be blue. You specify, and then you do a fill rect, the dimension. And then lastly, you want to draw a circle. So you set it to be yellow. And then instead of fill rect, you use fill oval. So when you do the homework, right, there might be some other shapes you want to draw. And how to find out those APIs, right, we call those APIs, is to look up in Java Docs or Google Online, right? Like maybe you'll type in something like Java applet drawing APIs or whatnot, yeah. But this is an example of how you can draw the diagram. Just go home and try it out, because you definitely want to be able to do this, because your first homework is going to be, part of it is going to be the drawing. And I'll just give away that it won't be something simple like this. I mean, you guys have a week break, right? So In this one, all that we're trying to do is to keep it center. Try to go see for yourself why is it that we have to keep it center. You might already, whoa, what happened? Oh. Hold on. You might wonder, why is it that we have to make sure that we keep it centered? Because like, shouldn't this code already keep it centered? The answer is no. I mean, you have to actually specify keeping the center yourself. And one thing I want to point out about what's so special about this paint method is that it is called every single time you resize your window, or you click or you do something. This paint method will get called every time. And I think maybe that's all that we have for the lecture. Let me go back to the other slide. So last thing now that I want to cover is how to do homework on Courseville. Let me see if I can log in. So assuming that you signed up Courseville, yeah, and you go in, I just want to take 1 minute to demonstrate how to do the homework. So this is a fake Facebook account I created last night to register as a student. So you go into April, right? And there's assignments. You'll see homework 1, and you see how long it is. Hey, so I guess you guys won't get to go to the south anymore. But oh crap! Hold on. I wanted to. Sorry. So by the way, the Courseville website is all Ajax, so don't do a back button. Yeah, just go through the navigation. So when you click on assignments, you can click here to do your homework and put your responses in here. I mean, part of it, not all of it. Like, for example, in part 3, I believe, this is where you can put in your part 3 submission or homework there. And then you put in, there are 10 questions, and then once you're done, just hit submit. This also supports HTML, I guess, Ajahn Atiwong. Yeah, so you can put HTML tag, but I don't think for this homework you really need to put HTML tag. Just reply to the questions. So just to cover real quickly, yeah, for homework. Crap, sorry. No, I didn't mean that. Because it's in incognito mode. So this is the applet. This is the first homework. Part A is avatar. So we covered applet, right? And your homework is to draw your face. We have the requirements listed here. Yeah, it should have shoulders, neck, teeth, or whatever. So you can go through this. Use applet. Use Java applet. Second one is Git your profile or learn how to use Git. So install Git on your computer, set up GitHub, very easy. Create.
So, I'm sorry. So, for the first one, you are going to write applets. Okay? Do not worry much about, we have little time to cover about the applets today. We can work it out. And we have the whole university game vacation, which seems now not a vacation anymore for students in this course, right? We will be glad to explain more about working on applets. It's just the first homework, so you will be writing applets for probably a few homeworks after this. So this is probably a test that, well, the test about whether you can do it on your own with minimum supervision. But do not worry much, we are happy to answer questions. The first one, you are going to write applets, and let me just touch upon the point about how to submit the homework. Is that if you go on to the course wheel that Ajahn Thach showed, you will have two places to answer your question. Could you please go to assignment and answering the questions. So you have your paper. So write the answers that are asked. For example, in the part B about Git your profile, you need to provide Git address and the Git commands. So you just type in here, right? Just like a piece of paper that you submit, right? And then in the bottom, there is an attachment there. Every homework will provide a slot corresponding to each part. In this case, you need to submit the source code, right? Not the bytecode, right? Source code for the applet. So use this function and it will be safely, hopefully, stored in the system and we can create that.
So I guess we should cover this homework real quickly, what they're supposed to do. So there's the applet, Git, creating a repository, and you're going to basically commit 2 files or push 2 files. Remember the concept of pushing to GitHub your image and your profile, and you can go through the description of what each one entails. And lastly is we have questions about the syllabus. So if you remember, I asked you to pay attention. Okay, so these are the 10 questions that have to do with the syllabus. It's not straightforward, I think. We put some twist in it. So those are the 3 parts that you have to work on. You should be thankful to Ajahn Atiwong because I actually had 4 parts and he took out 1. So
actually, I have another proposal that the students might be glad to hear.
Glad to hear?
Yeah. Well, the proposal to Ajahn Thach is that how about we focus on the Git part and the syllabus part first? Because you need to learn how to do source control, and we will not teach you that. You can read about Git and GitHub, and that part you can do that by yourself, right? So the proposal to Ajahn Thach is that we reduce this homework to just part B and part C, and we will touch just a little bit, touch upon applets again after the university game. Because you're going to need to write applets for a few homeworks, right? That might be, well, let's vote. Who say second plan? Raise your hand.
Only C.
That's not that choice. Only C? You mean for us to keep out only C and okay. That's not what you meant, right? Okay, I almost misunderstood. All right. So, and so that we can double homework too, to be like 4 times heavier than this. All right. So let me just quickly say this. I know we ran over time. Okay. So to make everything that Ajahn Thach said short is that this course we are studying programming. But it will be different than the first class, the 101 programming, is that Nobody in the world to write sensible applications today write things from scratch. They rely on parts that people invented. And to be able to rely on parts that people invented, you need to understand conventions, you need to understand paradigms, you need to understand how to use what is called application frameworks. Application frameworks, which will be introduced in a couple of weeks, are just part of codes that people already built, and it's partially work. Of course, when we would like to create our own application, it will not be exactly the same as what people put in the frameworks. But when people design frameworks, they create things that kind of they imagine, they think that it's going to be generic, it's going to be general, it's going to be useful for many people. Right? For us, programmers, in order to create software, in order to create computer applications, nowadays we take those classes, we implement those interfaces in the frameworks and just overwrite. Still remember the word overwrite? That's going to come into place a lot. We overwrite the behaviors of the parts that we would like to customize. For example, Java applet. You will not see the public static void main in there because it's not a full Java program. It is just like a definition of a class. By applet itself, it can be embedded in the web browser. And web browser somehow knows how to run the applet because it somehow knows what to do with the applet class, right? But originally, the applet is just going to show a blank canvas, blank thing on your web browser space. That's not what you want. You want to draw, for example, in the X homework part A, right? You need to draw your avatar. The original applet does not give you the answer, right? Because it just paints something white on screen. You need to change the behavior of that class, right? Instead of writing the whole program to talk with web browsers and show something on screen, you will not do that. You can just adopt or extend, all right? Technical term extends the applet class. That means you take the applet and then you tweak, you overwrite specific methods. And it just happened that the design of the applet is that web browser, whenever it needs to paint the area belong to the applet on screen, it automatically calls some method that eventually invoke the method paint of the class, of the applet class. Default behavior is that it's just plain black thing on screen. So that is a place that you override, right? You create a class, you extend your applet, you override. That means you create public, void, paint, graphics. That method is already there. It is there inside the applet, but you override the method, right? So the task when you need to do this, revisit this homework is that another part that you need to practice is that you have seen from Jan Pak's examples, g.drawString, g.drawOval, g.fillOval, right? There are probably hundreds of these things inside the graphic class. G is an instance of a graphic class if you go back and look at the code, right? Another ability that we expect you to gain when you finish all these courses with an A to whatever, right, is that nobody can cover all the methods, but you need to understand the paradigms, you need to understand the concept so that you read the documents and you know how to use that. Suppose you draw your avatar and you consider that your face is square. So you're going to need to seek out the method, which one that serves your purpose, things like that, right? We will carry this on after we will resume the class. But at this point, I would like to just let you to understand that the goal that we will practice in this course is to write programs, but not from scratch, right? We need to use application frameworks, and you will be exposed to Rails. You write Ruby on Rails, you will be exposed to writing C# or VB.NET on .NET frameworks, or if time permits, you will be write Java on Android frameworks, things like that. Okay, so let me pass the mic back to our main instructor.
Thank you, Dr. Wong. So, yeah, I know that we didn't cover so much today, and I might have missed quite a few things that you need for your homework, but since Ajahn Wong is so nice to you, yeah, you only have to do part B and C. So if you have any questions about part B, yeah, fortunately I did not get a chance to cover so much today. Just feel free to send me a Facebook message or email.
We will post more documents. Right? We will post more documents.
Yeah.
Probably we will not just directly tell you every step, but our intention is that we will post you pointers to the document that you will read and learn and will basically adopt the tools and practice with the tools.
Right. So we'll be posting some helpful resources for you, yeah, and hopefully it'll help make your homework easier. So that's it. Have a good week off, and see you 2 weeks from now. Huh. So how come it doesn't show up?พอดีผมพยายามจะเช็คว่าทำไมมันถึงไม่ขึ้น เมื่อกี้มันหลุดไปเดี๋ยวผมลองดูเดี๋ยวนะฮะลองดูว่าโอเคแล้วก็โอเคนั่นสีเหลืองคงจะขึ้นแล้วมั้งเดี๋ยวแป๊บนึง No source found แปลกก็เมื่อกี้ยังเวิร์กอยู่เลยอ๋อได้ละแล้วone more question ฮะอันนี้นี่เปิดไงเปิดอีเมลก่อนอ๋อตัวนี้ครับขอบคุณนะครับก็โอเค thank you เพื่อที่จะเปลี่ยนมาเลยใช่ไหมโอเคขอบคุณครับ Man, would I be able to program on this? Let me see. Okay, good. I think this is a bit better. All right, so the next thing that we want to cover. All right, real quickly, I know that I owed you Windows user this. Basically, how to launch the command line from Windows is just type in CMD. Did you guys catch that? Just type in CMD when you press start, and then just type in CMD, it'll launch the command line here. And we'll cover like what you can do or why you have to care about command line, but at least I want you guys to know how to launch the command line. Everyone can hear me okay? Okay, so now I'm gonna turn off parallel desktop because it's really resource consuming. Suspend. All right. So we really have a lot to cover today. You know what? I'm going to skip JUnit because I feel like if I cover it now, we won't have time to cover other things. I want to cover the first thing that you should know about your homework, which is source control. So, whoa. I just lost it again. Hold on. Okay, then do this. All right. So who have used source code control? Some form. Which one did you use? Git? Perfect. Because we'll be covering Git today. Whoops. Privacy, privacy. So, who have used source code control before? One? None? Okay. The rest of you haven't used source code control, that's fine. I want to first cover why is it that you should care about source code control, the rationale behind it, and how to use it. Okay. All right. Oh. So I don't know if you guys got to do these things when you were when you took the Java lab, but when I was an undergrad, when I had to work with my friends, or when he asked me for help to share my source code, back then we used email to share our source code. Okay, or when we when we were assigned to work in a group, it was actually very difficult to work together because we did not have a centralized location of where we store our source code. And what was worse was when you were working at 2 or 3 a.m. in the morning and you messed up by for example, you ended up deleting certain parts of your code and you just lost it forever because you just accidentally, I don't know, close your program or whatnot. Point being is that if you didn't have something to help back up your code, things can happen, yeah? And it could cause it to such that you lose that code forever. I haven't had this happen to me yet, but a few of my friends, true stories, they were working on their project which took them 2-3 weeks, and then suddenly they lost their laptop and they didn't have anything besides their laptop to back up the code. So they lost 3 weeks worth of work because they did not have some other means of backup to back up their source code. And also, last thing is that sometimes, and those of you who have programmed will know what I'm talking about, but sometimes when you work on your code for a while, you discover that you made a mistake, or you want to sort of roll back to the previous work that you did. Without source code control, you can't really easily roll back unless you actually made a separate backup, another version backup somewhere else. So without source code control, like Git, you run into these problems, even if you use Dropbox. Because Dropbox, even though it's great for sharing stuff, but it was not created to share source code because it doesn't understand conflict management, or it doesn't have logs where you can easily see what you've done. So with all that being said, I want to introduce you to an application that you can use to help manage your source code. And it is my hope that you'll actually use it as part of your daily programmer life. So the tool that we'll be introducing is called Git. And I also put another application called Subversion, okay, just in case. There are two of them. I mean, those two are the most popular source control systems today. One is called Git on the left-hand side. The other one is called Subversion. The reason why it's Turtles SVN is because that's the client application. But let's just remember that there are two most popular source control systems today. One's called Git, the other one is called Subversion. For the purpose of this course, the one tool that we will introduce you is the one on the left called Git, which is more recent, so it's newer. So when you use Git and along with the, when you use Git properly, all the problems that I listed before will disappear. You won't have to use emails to share your source code with your friends anymore. You actually share your source code through this application called Git. You'll have backups, okay? And I'll show you what I mean by physical redundancy today. You have backups of the code somewhere that even if you lost your laptop today, okay, you'll still be able to recover your code. And I'll show you how. With Git, you can have multiple team members work together on a single source code, centralized, stored centrally somewhere, and allow you guys to work concurrently together. And you can also see logs of things that you've done to your source code as well. So these are the things that Git can provide for you, or source control can provide for you. So I know it sounds very theoretical, but I'm going to show you like real life example of how to use Git. So this slide is just showing you like different type of version control, but you don't really have to know this. So I'm going to cover now the Git and GitHub, how to use it. But before that, let me sort of draw visually what I'm talking about. Okay, I have like 5 minutes. Okay. So how does Git work? What do you think this is?
Computer.
Good. What's your name? We. All right. It's not zooming that well. Okay. All right. This is her laptop, yeah? So we today you're going to be the unlucky person and assume that you don't know about Git yet. So, you know, I'm going to assign you some project, programming project, yeah? And, you know, you've been working on it for 3 weeks now, and suddenly Methat came. Okay, so this is we, yeah? We're not going to go there. Just to make sure that it's like, does this look like a girl now? Methat, here. This is your hair. Not today. So this is we and this is Methat, yeah? And I want to demonstrate a scenario where you don't have stuff backup. What happens? So Methat comes in and he doesn't have a laptop. So now he steals it from we. So now we's laptop is here. And now, and this is Ajahn Natiwong. So since we does not have the laptop anymore, can she turn in her homework? No, because all her source code is stored here, right? Okay, so that's one scenario, scenario one. Second scenario, sign. I can't see you, but I don't know how to draw you properly. So you just look like we again, huh? See, sign, even though she sits way back, right? But she actually pays attention. So she installed Git on her machine. That's a really messed up laptop. Anyway, so she has Git installed on her machine, and it's the same thing. She's been working on her code for 3 weeks. Medhat also wants to steal another laptop because now he has one, right? The second one, he's going to sell it for profit. But the difference is that, okay, this is Medhat. Okay, but you see, with Git, once you install it, okay, one of the things that you can do is that you can tell Git to say, hey, Git, can you store my code somewhere else in the cloud? So you can push, okay? You can push, the term is called push. You can push your code or quote unquote backup to the cloud somewhere else. And one of the places where you can actually push the code, your code to a backup for free is a website called GitHub. And it's one of the most popular social coding website social code backup that people use. So it's called GitHub. So Sign is smart, yeah? She's been backing up her stuff to GitHub all these times. So my question is now, when Medhat come in and sneak to try to steal the laptop, do you think that Sign will cry? Yes. Yes, she will cry too. Okay, you're right. Dang it. But you know, her dad is pretty generous, so he bought her another laptop. Let me rephrase the question. Can she recover her code?
Yes.
Yes. Why? Why? Come on, it's not that.
Because she has pushed her code.
Right. Because she can recover her code from something called GitHub, which is external server that's not at her house, is somewhere else in the cloud. Yeah. So this is the concept of the cloud. You know, you don't have to know where it's stored. It's stored somewhere. So this is the important point. The first point is that with Git, you can have this. You can have this. Yeah. It has the facility to allow you to back up your code somewhere else, so that in the case of your hard drive failure or Medhat stealing your laptop, you have a backup. And you might not you're asking what's the big deal? But wait until it actually happens to you, and it's like 2 days away from the homework submission. So learn how to use Git, okay? And I'm going to teach you how today. Okay, so I just want to sort of show you the diagram of how Git and GitHub works. Now I'm going to start showing you how to use it. And this works the same way, whether it's Windows, Mac, Linux, because the tool that we'll be using is the terminal. Let me see. So I had alluded to you about GitHub, yeah? So once you go to GitHub, if I can access it. Why is it so slow? So I'm pinging Google, and it's responding. So that is pretty common when your internet is not working. But for some reason we can't We can't access GitHub. What's wrong? Oops. Okay. Huh? What? Maybe I have to like sign up again. Huh, okay. What's wrong? Okay. This should work now. Huh. Why? What the heck? I don't know why it doesn't work. For some reason, Chrome doesn't work. Yeah, I can't access the internet using Chrome. That's strange. Man, we don't have much time either. You'll need to know because of your homework. Okay. Okay. So we still have quite a bit of stuff to cover. The first thing that I want to ask you guys is, why is it that we have to learn about object-oriented? Or why was object-oriented invented? How does it help us? Well, before you answer that question, let me say something about everything that we have to learn, or anything about software engineering. Everything has a purpose, yeah? Things that you learn from programming, they all have a purpose, and they are supposed to make your life easier, make things more convenient. So the question that I'm actually asking is that, why is it that if we look at object-oriented as a technique, how does it help us build better programs? why is object-oriented something that we should learn about? Anyone has any ideas? The hint is sort of on the slide. Anyone wants to take a crack? Well, at first when I started learning programming, I just used class or OO as a way to just following it. Like I just used it because it was there. I did not really understand why we had to use it. But after a while, I learned that object-oriented actually helps you structure your program in a more organized way. In other words, you take components of your system, your software, and separate them into different objects or classes. Yeah, and this I think that it can be easily said, but to internalize it, to actually to have that eureka moment that, oh, okay, so it actually is helping you instead of like more boilerplate code. It takes time, it takes practice. But if I had to explain why is it that object-oriented is something that helps you make code better, is because it helps you organize your thoughts into different components. Okay? And the best programmers are the ones that can separate them, like different parts of the system, into components well enough, and then also make them able to interact well enough. This is why when you look at this slide, you see many different boxes, right? So the program is being separated into different components. And the reason why you have lines going from one box to another is because these objects come together and communicate so that as a whole, it does what you want the application to do. So you see, this is why the definition says OOP is a programming paradigm that uses objects, right, different components, and their interactions to design a program. Again, maybe if I'm sitting like where you're sitting right now and listening to me talking like this, you might not really see it yet. But through practice, through countless hours programming, there'll be that day that you see, oh, yeah, it does make sense. I mean, how could it be otherwise? Yeah. So again, just to rephrase, a program is a result of cooperating objects. The word is cooperating, yeah? They're supposed to work together. The bad programmers are the ones that make a bunch of objects, but none of them actually cooperate. They don't really work well together. How do you measure that? How do you measure a program that is non-cooperative? Well, when you see gazillion objects and the APIs, like the method calls, they don't make sense at all. I call that not cooperative. Each object is capable of receiving message, processing data, and sending message. In this sense, when we say receiving message, that's equivalent in Java. It's equivalent to like when you make a method call. You guys know a method call, right? Like when you have an object instantiated and you like make a method call. Yeah. All right. We're a bit short on time, so I'm going to have to skip the history of OOP. If you guys are interested, you guys can read about that. Objects and classes. So we want to be clear on what we mean by object and class. In a nutshell, the way that I see the distinction is that you have class. You guys all know what a class is, right? It's a class that you create with a keyword class in Java. And a class will have attributes and methods, right? Okay. So what's an object then? An object is an instantiation of the class, right? So you'll have one class, but you can have many objects, right? So these are objects. Object 1, object 2. And in the later slides, we will define, how do you measure how do you determine if the two objects are of the same identity or not in the later slides. But I hope this is clear that you instantiate an object from the class, yeah? So this is the point of this slide. So as we have alluded earlier, right? A class can have attributes and methods. So who can give me an example of a class that you've used before in Java? Or maybe just give me an example, like a car. That looks like a UFO, no? Okay, I don't know what brand is that, but I wouldn't buy it. So if we're talking about attributes, what do you think are the attributes of a car? What? What? Model. Oh, the model of the car, right? Oh, hold on. Let me get a better pen. Okay. So, attribute and methods. Boy. So what are the attributes of a car? So she said model, right? The model of the car. What else? Model comes with make. Okay, we only need two. You guys, so these are examples of attributes. Properties or, things, characteristic of the car, right? What about methods? What are some sort of the methods that can be associated with a car? Can it fly? Oh, sorry, I gave away answer already. But okay, what are the methods that a car can have? In the future, yeah, maybe. Run. What else? Park.
Crash.
Okay, crash. No. Right? So in other words, the way that I view methods, they're sort of like you asking, it's a verb, right? What can this class do? It can run, a car can run, can park, can crash, drift. And what are the attributes? Like, what are the colors? How many wheels does it have, right? So that's the difference between what? Attribute and method, right? And when you model your class, that's what you should be thinking, yeah? Private members are attributes, yeah? Or, attributes. And then the methods associated with it are things that that class can do, okay? So object-oriented comes with quite a number of concepts. Modularity, abstraction, encapsulation, and polymorphism. So who's familiar with the term called polymorphism? You guys ever had to use that in your lab yet? Inheritance, abstract class. We'll have an example of polymorphism. And I'll try my best to cover the rationale. Why is it that we had to create polymorphism? I want to tell you a little bit about Java. It was created as the next language after C. What is the paradigm of the C language? Has anyone heard of the C language? What's the paradigm? Do you guys remember? Procedural, right? The defining characteristic of procedural paradigm is anything that it just functions. So when you think of procedural, basically, if you know C, you know that you don't have class in C, right? You have struct, but you don't have class. Java is supposed to be the continuation or the better version, the next version. So OO is associated with class and class, polymorphism and all that. So there's a reason why they invented this object-oriented in this class. Is because it's supposed to allow you to better model your code. And I'll show you a specific example. It's supposed to make your life easier. So the key takeaway that I want to say is that if you find that, if you know C, and once you come into Java and OO, if you found that your code is actually messier, like more complicated than if you coded the same if you solve the same problem using C, you're doing something wrong. I'm not saying that all problems are best suited to be solved by object-oriented. There are certain problems that are best solved by functions or procedural paradigm as well. But a lot of people, when they first come from procedural paradigm to object-oriented, they still don't understand the paradigm, and because of that, they misuse it. So that's just one thing that I want to say, is that object-oriented is supposed to simplify your code. And we'll show specific examples through these concepts. All of these concepts, are supposed to solve what procedural could not. And I'm going to demonstrate in the next slide. We'll start with modularity. Let me see if there's, as I had alluded earlier, right? Procedural paradigm is what? It's actually just a lot of functions. If you look at like C program, you'll see that it's all composed of just a bunch of functions together, right? Some problems are best suited for that. I mean, example of problems that are really procedural are like math functions, sine, cosine, tangent, power. Those are just functions, right? You can solve them by functions. But it's very hard to group them together without class. Because like with class, with modularity, for example, you can maybe create a class called math, and you can have like a bunch of functions like sine, cosine. So in other words, the first concept that I want to introduce you guys is that with class, you can sort of group things together. You know, modularity. You can separate things like maybe, you know, this is trig, right? So sine, cosine, tan. And then you can separate into another class or another package called, let's say, just simple math. And these functions are like power, what else? Absolute. You guys know these basic math functions, right? So this is one thing that modularity or object-oriented gives you, is that the ability for you to separate your programs into different modules. This is what we mean by modularity. Abstraction and encapsulation. What do you think abstraction and encapsulation do for us? Like, why is it that in this slide we have the picture of the phone on the left, and we have, you know, more details about what the phone is composed of on the right? What is it trying to convey to us? What do you think? Oh, you thought. Hey, have you guys ever seen that YouTube video where like the professor is giving lecture, and then like the student is on the phone, and then he threw the phone on the ground? We're not gonna do that stunt because I think his phone is probably pretty expensive. But anyway, back to abstraction and encapsulation. Oh, maybe I should ask. So Anyone has heard of these terms? Encapsulation, abstraction? No? Yes? In a nutshell, let me ask you this. So how many of you use iPhones? Okay, most of you. So we'll use that as an example, since this is a cell phone example too. Do you care? Did you know that the iPhone 5 is powered by the A5 processor? I think it's A5. I'm just making it up. But anyway, I mean, A5. Let's just say it's A5. Is it A6? I don't know. Yeah, some processor. Do you? I mean, that's a fact that. I mean, do you have, as a user? I'm asking as a user. Do you have to know that the iPhone is powered by the Apple A5 processor? How about the fact that maybe the battery was made in China? Do you have to know that? No, right? I mean, as a user, what do you care about? How to use it, right? How to like maybe download Instagram, Facebook, right? Yeah, how to take pictures before you eat. By the way, for those foreigners, I want to introduce you to something that is very Thai, because I have quite a few foreign friends, yeah, and they're really quite surprised about this behavior of Thais, in particular maybe Asians. Well, let me take that back. I have Singaporean friends too, and they don't do this. This is a very Thai thing. Well, anyway, so let me tell you what we do sometimes, or most of the time. We always take pictures of the food that we order before we eat, and we upload them on YouTube. I mean, no, not YouTube, Facebook or Instagram. I mean, and I don't know why we do that. I mean, I think, why do we do that? Keep track of what we eat? But that's something that we do. We do that a lot. It's a very Thai thing. Why did I bring that up? I don't even know how it's related to abstraction. Anyway, so going back to the example. So, oh yeah, iPhone, right? You take photos. So as a user, we care about being able to use the camera, use Instagram, Facebook, WhatsApp, right? Line. We don't care that the phone was made in China by laborers that work for like $1 an hour, right? We don't care about that. So the point that I'm trying to say is this. This is what abstraction and encapsulation buy you, is that if you look at the phone on the left-hand side as the class that you're being given, all you care about is that how you use that class. You don't care about the implementation underneath. This is what abstraction and encapsulation, abstraction buy you, and also you just want to, you see, this is why the description says you want to separate the essential from the non-essential characteristics. Essential being, how to use this class, for example. Does that make more sense? So when you build the class, when you create your class, think about how you plan to use that class, right? Think first about how you plan to use that class to solve the problem you're trying to solve. And then think about the implementation. Yeah. See, and this is the term that we have, yeah? The implementation of a module, right? The stuff underneath should be separated from its contractual interface and hidden from the clients of the module. So to apply this to iPhone, right? You want to know how to take pictures with the iPhone, but you don't care if the lens was made from, I don't know, some company like Canon, Samsung, right? This is what we mean by, so the interface is the camera, and the implementation is like how the camera was built, what brand and what lens they use. And this is an example, yeah. When I'm looking at this service provider, this class, I'm seeing that for the phone, we have the interface of like being able to make the call, hang up the current call, add some address book items. So these are the interface for the cell phones. Yeah, I mean, these are the things that we do for our cell phones. Okay, polymorphism. I looked up on how to best explain polymorphism, and the best way that I can explain it that makes sense to me is that we have to first start off with without polymorphism. Without polymorphism, okay, let me see. So who knows about inheritance? Okay. Man, I never thought. Okay. I wonder if well, maybe I'll just first start by defining what polymorphism is, and then we'll go into details later. But polymorphism basically is, in object-oriented, there's a way that you can have you can have an object that have like some function call, let's say run, but that function call can actually behave differently based on what the subclass is. Okay, this does not make sense. I'm going to have to cover some other concepts first before we talk about polymorphism. Okay, UML notation for classes. This is something easier. Okay. So you guys know about class, right? I'm going to draw a really simple example of. So this is not strictly Java, but I think it will prove the point. Private X, private Y. So my question is, how many attributes does this class have? Can you guys see? How many attributes? 2, right? And how many methods? 1. To model this using the UML, so if you had to explain this class to your friend without having to like write out all the code, one of the standardized way of conveying this class information to other people is through what we call a UML diagram. A UML diagram is basically a representation of a class. So to apply it to this example, so you'll have the class name, which is in this case circle, and then you have attributes. What are the attributes? X and Y, and then the method is draw, right? And you can actually specify the accessibility of the method and the attribute as well from that. So let me just show you what it looks like. So in this case, when it's private, we denote, so this is private, we can denote it in UML with the minus sign. And if it's public, we can denote it with plus. So for example, if this is integer, yeah, all integer, okay. In this example, what do you think would be the sign in front of X? Negative, because it's private, right? What about Y? Negative as well, yeah. And these are the things that, so, you know, if someone knows about this UML diagram, he can quickly infer from the diagram, okay, the structure of this class, right? So this is an example of the diagram. And also you can denote like the type, right, with colon, int, yeah. So this is what we expect you to know for the exams as well, UML diagrams. So you can sort of look through from this slide to understand the UML. So for this case, if I denote this as public, what do you think will be in front of draw? Plus, because it's public, right? And if it took, so how would you read this part right here where it says j colon int? That would be this would be the, what do you call it? Identifier, right? Followed by the type of that identifier, which is an integer. So if we were to expand this out, like the last line of do action 1 jint, in Java it will look like this. Or Boolean, right? It's the return value. Do action 1 of type int j and string s. Yeah. So this is in Java. Like just think of this as like a line in Java. If you had to write it in UML diagram, you would just do that. And also, like I forgot to denote, this is private. Is that clear? Yeah. So it's pretty, I'd say pretty simple. I mean, once you get everything, you know, the plus, the pound sign, squiggly, and minus, it's pretty easy to read a UML diagram. And the reason why they had to do all these things, like have a different notation, is because UML diagram is not only applicable to Java, right? You can program in C++ and you can apply UML notation to C++ program as well. This is why they had to invent their own language, yeah, UML language. Okay, these are just some terminologies. You guys already know about attributes. We covered methods. And the two new terms that I want to just mention real quick are mutators and accessors. Or the simpler terms are like getters and setters. So the only difference between accessors and mutators is that the mutators, they actually mutate or change the attribute of your class. What do I mean by mutators, change the attribute of your class? Well, the class in question that we're talking about now is called point, right? And some of the two behaviors that this class supports are setX and setY. When you call those two functions, passing in some integer, it will change the attribute. Is that right? Is that right? This is why it's called mutators or setters. On the other hand, you can access X and Y through get X naught and get Y naught as well, right? So just some terminologies that we want to cover. So the key from here is that when you model your class methods, there will be two types. Either it changes the behavior of the class or it retrieves the behavior, or either it sets the state of the class or it retrieves the state of the current class. Yeah. I'd like to add that when you retrieve the state of the class or the getters, sometimes you actually don't just retrieve the state of the class. You can also have some computation as well, right? Additional computation. By that I mean, maybe in this class, if you wanted to implement like a function called getArea, you wouldn't just obtain X and Y, right? You actually need some more information to calculate the area. Oh, I mean, well, okay, if it was a circle, right? I mean, if the class is circle, you can have getArea, and in that you can, you know, put in the pi r square equation to calculate the area of the circle. Okay, So next thing we want to cover for the UML notation is the UML notation for objects. I think it's pretty self-explanatory, yeah? The difference between the class notation, the class UML notation, and the UML notation for objects is that first you have to ask yourself, what's the difference between class and object that we covered? Remember? I'll just say class is just sort of like a template, right? But you instantiate objects from them. And the real difference is that objects actually have specific values for each attribute. In this case, for example, we have two objects of type point, and the state of each point is different. You can see this is why we have x0 and y0 and x10 and y15, right? So these two boxes represent different objects, right? Even though they were instantiated from the same class. And you can see that the UML notation, to denote the value, you just set equal to some value. Yeah. And then this is the identifier, right? So in this case, we have P1 and P2. So if we look at it in terms of the code, you probably will have something like this. Point P1 is equal to new of point right? And then if the constructor, I hope you guys remember the constructor. If you actually pass in like 0, 0, and 10, 15 here, then it'll just look exactly like that, yeah? You can read that fine. So point P1 is equal to new of point class, the point class, passing in the two values, right, x and y. Same thing here, we're passing in 10 and 15, yeah? So far, so good. All right, for this class, we ask you that when you submit your homework, you follow this convention. It's very important that we all have the same convention. By convention, I mean like how you name your class, how you name your attribute method names. So I want you to help me. We're gonna like create a class following this convention. So if I say, all right, the class that we're trying to build is a person. So class name should begin with uppercase letters. What does that mean? If I wanted to build class person, capital P, right? Yeah. So capital P. Okay. Attribute and method names should begin with lowercase letters. So we're going to start off with attributes. So what can a person have? What sort of attribute can you have? I'll just pick on someone. We're going to need just two. You in the back. This. What's his name? Help me. The guy. Yeah, you. What attribute do you want a person to have? How to speak up. Oh, what sort of attribute do you want a person to have? Like a private member, anything? Help him. Attribute for a person. Height, perfect. So private. So following that, it should be all lowercase, right? Because it says should begin with lowercase letters. So now, okay, sorry. So let's say that height is measured in double. Okay. Give me another attribute that is two words. First name, perfect. Private, first name is string, right? The type is string. Okay, if you look at what? The third, the fourth, if a name consists of multiple words, it is formed by concatenating the words and capitalizing each word except the first. So what do you think this will look like? Perfect. Yes. The first. All right. So these are the attributes. I want to cover the methods now, and I want to take the time to actually cover this because, like, if you submit your homework, I mean, I'm just afraid that if I don't explicitly cover it, then you guys will not follow it. Because like you have to read a lot of words. So, all right, next is the method name. Follow, what is the, give me a method name. Okay, girls. You, yeah. Speak up. Read the rules and tell me. Huh? A person. What can a person do? Yeah, drink. Huh? But I want to hear it from you. Dance? Yeah. Are you supposed to return anything when you dance? The return argument. Void, right? All right, the last one. So, what is a constant that we all have? A number. Oh, really? Constant. What do you think we have like that is constant? Oh, yeah, the number of eyes, huh? Wait, is that true all the time? Huh? Okay, at least we have one heart, yeah? This is a very bad, I mean, maybe it's a bad example, but... Okay, so how should I... Let's say if I want to say numb heart. How should I do it? Private int and then what? Follow that. All uppercase, right? And then num, and then underscore. What's the value? What's the value? You with the red eyeglasses. Yeah, you. 1. Okay, good. So now that I've covered this, you guys better not mess up, yeah? If you actually don't follow this convention, we'll have the TA mark points off. No, I'm serious. I mean, it's good to follow a convention, man. I mean, when I first, started working as a software developer, I had to go through code that were written by it felt like it was written by 10 different people. It's not fun, really. I mean, just follow this convention, and it's good convention. I mean, it's the same convention that the Java library or frameworks follow as well. So follow it, yeah? Don't invent your own convention. Okay, now we can talk about object equality. So the two terms that we want to talk about are equal and identical. I want, John, can we give some extra credits too? Well, anyway, we're not gonna give extra credit, but I want someone to read the slide and then come up here and give me an example of how to set it such that 2 objects are equal and that 2 objects are identical. Should be pretty straightforward. So whoever knows like how, I want you to come up here and write some Java code to demonstrate to me under what circumstance is equal and under what circumstance is identical. All right, maybe I'll just start. Because it's already up there, so I might as well just copy it. Point. Man, what's wrong with the pens? Point P1 is equal to new point, and then I pass 0 and 0, and point P2. So I just need one volunteer. Point 0, 0. And in this case, P1 is equal to P2. By that I mean they're equal. So this is one example. Now I want someone else to come up here and demonstrate to me how you write the Java code so that we have identical objects. It's very easy. Come up here. So that's equal, right? Yeah, good. Give him a round of applause. Right. So which two variables? Yes. So do you see? Okay. So now this is identical. By identical, we mean P3 and P2 are identical. So what's the difference between P1 and, equality and identical, or equal and identical? Sorry, there. Do you see the difference? P1, we say in this case P1 and P2 are equal, and in this case we say that P3 and P2 are identical. So if you read the slide, two objects are identical if they are the same object. By same object, we mean that if you look in the debugger, you'll see that the address of P3 and P2, they refer to the same address, right? Because right? If those of you who know C, you'll know that this is like pointer, right? They refer to the same object in the object space. So like P3 and P2, they're here, and then P1. So in memory space, this is P1 and that's P3 and P2. They refer to the same object. Yeah? And this is P1 to a different object. These two are equal because the attributes are the same, right? They have the same values, attributes. And these two, they're identical because they point to the same object in the memory space. Yeah? So maybe on the midterm exam, we might ask you to give an example, like write some code to demonstrate how to set objects to be equal and how to set them to be identical. Anyway, enough about that. Whoa. I want to cover applet. Packages is just how to group. So we talked about modularity, yeah? And package is just how you define, like, just like that example that I talked about, yeah? Right? The math and, what's the other one? Math and trig. This is just an example, right? You probably want to put absolute value function and power function under math package. So these are packages, yeah? And you want to put trig, like sine, cosine, under package trig, right? That's an example of how you could use package. Just a way to like sort of put names for different functions. Okay, so you would use the keyword package, yeah, pretty self-explanatory. And if you did not put the package declaration, then it automatically belongs to unnamed package. But my recommendation is that you always put package in front of your class. So how this reflects in so today we're gonna go over time just a bit, but so bear with me. But how it reflects in your file system is that each package will create like a new directory. So you see, very easy, right? pack1 with class C1, this is why you have this. And then when you have pack1.pack2, you have a subdirectory. Yeah, pretty self-explanatory. This is why C2 and CD2 are underneath pack2 or inside the pack2 folder. Let me see how much we have. So when you have package, right, you can't just, like for example, in this example, we're trying to instantiate C1, C2, and D2, but you can't really do it because it doesn't know, since it's in a different package, it doesn't know like where it's supposed to look. So you have to prefix or import the classes, telling it like which package before you can actually instantiate it. So we have inheritance. Inheritance is a technique to group in a single sentence. Inheritance is a way you group common behaviors and attributes into a single class and share it across many different classes. And that is the technical way to explain it, but the qualitative way to explain inheritance is that it's best to use this. You agree that student is a person, right? You agree that teacher is a person? Yeah? Student and teachers, they are both humans. What is the commonality between a teacher and a student, for example? What's something that's common? They're humans, they have legs. You see, so let's say that a class had an attribute leg, right? It's very time consuming, right? If you did not have inheritance, you had to declare the leg attribute for each one of these class. But if you had inheritance, right, you can just declare a class called person, put legs underneath that in that class, and then make two classes that inherit from that same class, so that you don't have to keep typing the same thing over and over. In other words, let me rephrase. Sorry. Inheritance is a way that you group common attribute and behavior or methods into the same class and share them among all the classes that make sense to share them. So in this case, when you have like a person, you can have student that extend or inherit from the student or the person class. So here's an example, yeah? A student can be like a non-degree, undergrad, or graduate. And then a graduate can be either a master or PhD candidate. So this is what we mean by a is-a relationship. Yeah, inheritance, that's what the inheritance tries to model, is the is-a relationship. Like, you can have multiple inheritance as well. The example that I used to like remember is like when you have a boat and I think a car. What's that vehicle called that can both like run and also like sail? Anyway, so you can have like something like that. I don't remember what it's called, but maybe we have an example. No. Anyway, point is, in Java you won't have multiple inheritance because the designer of the language found that multiple inheritance can really lead to design problems. So they just limit you to single inheritance. C++, on the other hand, allows you to have multiple inheritance. I personally feel that if you have multiple inheritance, you're doing something wrong most of the time. So it's good that Java only has single inheritance. The syntax, the Java syntax for inheritance is simply just extends. You see, so to visually represent this, you have class point, and you have two different colored point and size points. So a point, what's the commonality between point? A point has x and y, right? I mean, a point in a space has x and y location, right? And when you have colored point, well, you need to have color. And when you have size point, you gotta have size. So this is a demonstration of inheritance. Final class, basically a class that cannot be extended. So if we declare this class to be final, you can't extend it further. This is an example. If you set point to be final, class point to be final, you can't create a color point class. It will give you a syntax error. Okay, so let me skip this and get to Java applets. Java applets, the reason why you want to know this is because your first homework, you'll have to develop a applet application. So most of you probably don't see applets that often anymore, but they were prevalent when the web first started, and they wanted some sort of interactivity with the web. So basically, an applet is a Java application that you can embed into a web page. That's all. That's all you have to know. It's very similar to any other Java applications. So let me give an example. If you want to create a Java applet, this is all that you have to do. Like you do these imports, and you extend from applet. And the function that you have to implement is paint. So graphics, yeah, is the canvas that you're supposed to draw on. Man, too bad I can't like show you. But in this case, just think of the graphics G class as a canvas like this, right? And when you call draw string, it will draw some string on that canvas. So in this case, the 100, 100 is the pixel location. So it starts from top left. This is coordinate 0, 0. So 100 would be 100 here and 100 here. So this is the location. And then if you pass a string to it, it will draw that out. So I think that we have an example in the next slide. So you can go through the slide to see the description of each one. But this is what it will look like. So when you go into Eclipse, you build a new Java application. You put the code in exactly like this. This is what you'll see on the screen. I tried it last night or the night before. Still works. And this is a good way for you to get into Java programming, like from graphical point of view, because there's not much you have to do to get running. Because like when you started developing like GUI application, there's a lot more code that you have to write. So Jang Ji-wong, I think he created another drawing example. So we first started off by drawing text, right? Now you can actually draw these things. Very easy, right? You can think of the graphics G class as a pen. If you wanted to draw that diagram right there, what do you have to do first? You first have to draw the magenta square, right? So you draw that first. You set the color, you see. Let me see